As we are still in Module 4 and we're moving on to Topic B, Lesson 10, is a critical look at proportional relationships. And what we're going to do is we're going to go back to what you worked on in 7th grade, this idea of being proportional. The graph is a straight line going through 0, 0, but the main thing is that there's a constant. So we're going to go back and look at that and kind of figure out what I call the 8th grade way to do these type of problems. So let's start by, well, here's what I was talking about. Last year in 7th grade, we would find our k. And we'd find it by going our y divided by our x. And this k here was called our constant of proportionality. Okay, and then we could write an equation, y equals whatever k was times x. So we divide y by x to find out what our constant was, and then that's the number that we're multiplying all our x values by. So now let's jump into our table. Okay, so Paul walked 2 miles in 25 minutes. So we have our chart set up right here, and time's our independent variable. So we say that's our x variable, and distance, how far Paul travels, is going to depend on how far he walks. So that's our y. So in 2 miles, he walks 25 minutes. And again, it's not exactly like it doesn't, you don't just put it in order. 2 comes first, the miles come first. Your x is always going to be your independent variable. Okay, and in this case, or in most cases, it's going to be time. Okay, time is going to be independent. Distance or whatever is going to be based on time. And we're going to do it a lot with distance and time right now. So if I needed to fill out the rest of this table, there's a couple different ways we could do it. Could we simply double everything? Sure. We can make this 50 and this we can make 4. Okay. That was 25 times 2 and 2 times 2. We go 25 times 3 and get 75. Well, if I'm going to multiply my x by 3, I got to multiply my y by 3 and get 6. 25 times 4 is 100, so I'd have to go 2 times 4, which is 8. And hey, let's just multiply by 5. 25 times 5 is 125. 2 times 5 is 10. Now remember, I didn't read it yet. It says, how many miles can Paul walk in 137.5 minutes? And that's what we need to figure out, because that's going to come outside of our table here. So the 7th grade way of doing it would be to find our constant. Our constant, remember, is whatever our y value is divided by our x. So in this case, my y, I'm going to use any of these, but I'm going to take 2 and divide it by 50. And if I do that, that works out, if you take a calculator, I'm sorry, I totally, see, this is what happens when you rush. It's not 2 divided by 50, and I hope you're catching that mistake. It is 2 divided by 25. Hello, let's look at the same, or the right row here. So if I go 2 divided by 25, there it is, 0.08. So our constant is 0.08. Ooh, talk about sloppy. Let me just start over. And that would work for any of these. If I did 4 divided by 50, if I did 6 divided by 75, this constant's going to be the same. The constant's always going to be the same. That's what makes it proportional. I could write an equation, okay? Remember, my equation is just whatever my k is times x. And a lot of times it's helpful to change your variables so we know what they're talking about. So our x, we're talking about time. So maybe I would say 0.08 times t, time, or m for minutes. And y is our distance, our miles. So I might say distance equals 0.08 times t, okay? And honestly, either of these would work, okay? So if I wanted to figure out how far can Paul walk in 137.5 minutes, that is t, right? T, because that's minutes, is 137.5 minutes. That's why it's kind of helpful to change up our variable. T is time. So what I can do then is plug this in for t, and I can say that my distance is going to equal 0.08 times my t, 137.5. And if I did that into my calculator, maybe, you get 11. So our distance is going to be 11, and since I know it's distance, that's going to be miles. Okay. That's the 7th grade way of doing it. We have the 8th grade way of doing it. And the 8th grade way of doing it is to go back to the idea of the cross products. It's just my term 7th and 8th grade way of doing it. So what we're going to focus on is we're going to focus on writing down this distance in miles. Okay, so I'm going to say that Paul walks 2 miles in 25 minutes. And this way we're not as concerned. Well, I shouldn't say that. I was going to say we shouldn't be as concerned with which comes on top, but we kind of need to be. And then we're still going to use this idea of x, our independent variable, being minutes and y being miles. Okay, so I'm still going to set it up to y divided by x. Okay, because y is our number of miles. So I'm going to squeeze it in here, and x is our number of minutes. And I'm going to set up this proportion, this ratio. And when you do that, then we can just use cross products to solve. Here's what I mean. If I go 25 times y, remember for cross products, that has to equal 2 times x. Here's the kicker. Always solve for y. We're always solving for our dependent variable. Okay, solve for y. So if I'm solving for y, I have to get rid of the 25. Since it's 25 times y, I'm going to do the inverse, and I'm going to divide by 25. Whatever I do to one side, you do to the other. 25 divided by 25 is 1y, and then we get 2/25 x. Well, guess what 2/25 is? That's at 0.08 again. So this just works out to be 0.08x. Either one, okay? Or. So you can see either way you do it, you get the same answer. The cool thing is if we wanted to switch things up a little bit, and instead of using y and x, I'm just going to do the quick way here. Let's say I wanted to do d for miles and t for minutes. Well, I go 25 times d and 2 times t, and then I would do the same thing, and I get d equals 2/25 or 0.08 times t. All right. So anyway, this is the 8th grade way of doing it, is just to set up the ratio directly equal basically to our constant, our y divided by x, or in this case, d divided by t. Okay. And so let's look at an example that is going to look just like your homework. Okay, so we're using d's and t's and all this good stuff here. You might remember the DIRT formula. By DIRT in science class, you might have had distance equals rate times time. This R right here, that stands for your constant rate. There's the word constant. Constant rate. And constant rate is another word for your speed. So don't stress about this part. Just trust me on it. If I wanted to solve for R, solve for my rate, this really bad looking R I wrote right here. Since this is multiplying, I want to get rid of the t. I divide both sides by t. And I'd get R equals distance divided by time. Should sound familiar. I'm going to pause there for a second. I want to come over here. And it says Wesley walks at a constant speed from his house to school 1.5 miles away. It took him 25 minutes to get to school. What fraction represents his constant speed c? Constant speed. Well, I don't know why the variable changes, okay, but your R, that's your C. So instead of writing it like this, I'm going to write C equals distance divided by time. Don't stress about that, just trust me on that. Your constant speed C is distance divided by time. So what fraction represents as constant speed? And pay attention to this. This is what you're going to see in your homework. Well, it's going to be whatever the distance is divided by time. So look here. What's his distance, D? 1.5 miles. What's his time, T? 25 minutes. There's a fraction. That represents his distance divided by his time. So keep that same thought. You want to know how many miles he has walked after 15 minutes. Let Y represent the distance after 15 minutes of walking. Oh, we're still at 15 minutes here. Write a fraction that represents the constant speed C in terms of Y. Same thing. Your constant speed equals your distance divided by time. What is your distance? It's just Y. What is your time? 15 minutes. So Y miles in 15 minutes. Don't overthink it. We're just writing some fractions or actually some ratios to represent just some situations. So now we're going to take these two that we wrote and set it up as a proportion. Remember, a proportion just sets two ratios equal to each other. So we literally just set these equal to each other. 1.5 miles. I'm going to write the miles here. I'm going to move it over so I have room. 1.5 miles over 25 minutes. And the reason I'm writing the miles in minutes is because I want you to know when we set up a proportion, two ratios equal to each other, we got to line things up. So the miles have to stay across the miles. So that was part A. Here's part B. Y miles over 15 minutes. Hey, cross products. If we want to solve for how many miles you walked, we're just going to use cross products. 25 times y equals 1.5 times 15. And if you type that into calculator, I'm going to tell you get 22.5. Divide both sides by 25, not 22. And y, our number of miles, is 0.9. So near 0.9 miles. Last one, real quick. Now, y is the distance in miles, x is the minutes. So again, we know he walks 1.5 miles in 25 minutes. Now he's walking y miles, miles across from miles, in x minutes. And now we're going to get an equation using your cross products. And remember what I said in the first part there up top. Always solve for y. Divide by 25. Divide by 25. Y equals 0.06. Erase this little dot here. 0.06. Don't forget your x. Okay. Just a new way of finding an equation, really by still using our constant, but doing it all together in one step.